Good day. Welcome to another series of Chemistry Just Got Easier with DR Tutors. In today's class, we are going to be learning how to balance chemical equation. Let's take a look at what we have on the board. All equations must be balanced in order to comply with the law of conservation of matter. What is the law of conservation of matter? The law of conservation of matter states that in a chemical reaction, matter can neither be created nor destroyed. That is, atoms are neither created nor destroyed in a chemical reaction. In a chemical reaction, what you simply have is the rearrangement of atoms. For example, in this equation I have here on the board, we have KClO3 giving KCl and O2. You have the same atoms in the reactant and you also have them in the product, meaning you don't have a creation of atom, you don't have a destruction of atom. What you simply have is a rearrangement of atoms. Okay. Now, how are equations balanced? Equations are balanced through the use of coefficient in front of the formula and not by changing the subscript numbers within the formula of the product. In the previous class, we learned that coefficients such as, for example, if you have like now here you have 1, you don't write it because 1x is same as x. So coefficients are written in front of the compound or maybe elements, and these are suspects. When you write coefficient, for example, if I have 2 here, for example, this 2 is affecting everything here. Here you have 1 atom of potassium, that will be 2 times 1, 2. 2 times chlorine is 1, 2 times 1, 2, and oxygen is 3, 2 times 3 is 6. So in order to balance a chemical reaction, you use coefficients and you don't change the subscript in the product. So we are going to try to balance this equation and see how we do it. So we have potassium, chlorine, oxygen as part of the react element in the reactants. We have potassium, chlorine, and oxygen as element in the products. And the reactant, we have 1 atom of potassium. In the product, we also have 1 atom of potassium. In the reactants, we have 1 atom of chlorine. And in the product, we have 1 atom of chlorine. In the reactants, we have 3 atoms of oxygen. And we have 2 atoms of oxygen. So we see potassium, chlorine is both balanced in both the reactants and the products, but oxygen is not balanced. So we have to think of a way to make oxygen balanced. I remember when you want to balance an element or a compound, you don't change the subscript, you use coefficients. We are going to take what coefficients can we use. So we have 3, we have 2. And I want this to be equal to this. So I think what number will give me something that will make 3, that will turn 3 to be equals to, that will make this oxygen here to be equals to this oxygen here. What about 6? So if I multiply here by 2, I multiply here by 3. So let's see. Maybe wherever I have oxygen in the reactant, I'm going to put 2 as a coefficient. And wherever I have oxygen in a product, I'm going to put 3 as a coefficient. So let's go. So I have oxygen here, so I'm going to put 2 as a coefficient. So you have 2 KClO3 solid. Remember, the equation tells us the state of the reaction. KCl still 1 plus here you have 3. Here you have oxygen, so it's going to be 3O2 gas, and this is solid. So now let's try to calculate the number of atoms of the reactants and products on both sides. Potassium, chlorine, oxygen, potassium, chlorine, oxygen. So potassium. So yeah, remember I told you that the coefficient affect everything in the reactants. Wherever you have the coefficient affect everything in the compound. So here you have 1 atom of chlorine times the coefficient, that is 2. So 1 times 2, the number of potassium is 2. For chlorine, 1 atom of chlorine times the coefficient, which is 2. 1 times 2 is 2. For oxygen, 3. 3 times 2 is 6. Now let's turn to the products. Potassium is still 1. Chlorine is still 1. Oxygen, which is 3 as a coefficient and you have 2 atoms, 3 times 2, that's a 6. Now, let's see. Potassium is no longer balanced. Chlorine is no longer balanced because you have 2 here, you have 1 here, 2 here, 1 here. While oxygen, we have 6, 6. Oxygen is balanced. So let's try to see if we can balance potassium and chlorine. So we have 2 here. So how do we make this to be equal to this? Using a coefficient, that means we multiply this by 2. So if we multiply this by 2, it means we are going to add 2 as a coefficient to where you have potassium on the right hand side. So breaking down this equation now, 2 KClO3 solid to give. Now, okay. Remember, where is 1 times 2, and potassium on the product side is there. So I'm going to say 2 KCl solid plus 3O2 gas. So what do we have here? K is 2, Cl is 2, and oxygen 2 times 3 is 6. Yeah, let's do potassium. Potassium, we have 2 times 1, which is 2. Chlorine, 2 times 1, which is 2. And oxygen, 3 times 2, which is 6. So let's see. Potassium is 2. Potassium is also 2 on the product side. Chlorine is 2 in the reactant. Chlorine is 2 on the product side. Oxygen is 6 on the reactant, and oxygen is 6 on the product side. So we can see we have the same number of atoms in the reactant and in the product, which shows that our equation is balanced. And if you want to check the mass of the reactant, if you want to know if it is equal to the mass of the product, let's do a quick check of that. So checking the product, the mass of the reactant, potassium, we have 2 atoms. The relative atomic mass of potassium is 39. Chlorine is 35.5. Oxygen is 16. And here you have the same thing. So 2 times 39 gives 78 plus 71 plus 96. So given the reactant and the product, so we have the mass of the reactants. Remember the law of conservation of mass. The mass of the reactants must equal to the mass of the product. So saying to 2 times 39, you have 78 plus 71 plus 6 times 16, you have 96. Of course, when you input this value into the calculator, you should have the same answer. So let's quickly do that yet. 78 plus 71 plus 96. So 6 plus 8 is 14 plus 1, 15, 1, 17, and 24. So you have 245 gram and 245 gram. So yes, we are correct, because after we balance the equation, we can see that it obeys the law of conservation of matter, which is that atoms are neither created nor destroyed in a chemical reaction, and the mass of the reactant must be equal to the mass of the product. I hope you enjoyed this class. Thank you for listening. See you in the next class.